These are the notes based upon the Blockade video that Jonathan shot. The first pictures we're looking at is just how the fire department set up their test burn with individual tires and then a little pile of tires. The tires were all bathed in diesel fuel as an accelerant to get the tires hot enough so they would burn completely and get the temperature where the tires would melt. In this scenario, as we look at it, the first two sets of tires, which were the individual tires, were extinguished, the first one being with water, the second one being National Foam, and the third set, the larger, using fire blockade. Each set of tires was given a 2.5 gallon extinguisher to use, filled with by the fire departments with water, National Foam, and with fire blockade. So what we're viewing now is just them getting the ignition source, the diesel fuel, ignited and allowing the tires to burn to get to a point where they would stay in ignition. The reason the fire department was using the tires is simply because the tire, when it gets hot enough, the hydrocarbons associated with the tire making process, the petroleum products, act as their own accelerant, and so they get hot enough to burn, and then they become a fuel for the same fire. And you see here, gentlemen, that is really, really making sure the set of tires we're going to be fighting are hot. You see an over limit. Those particular heat guns had a maximum capacity of 1,000 degrees. So when you see the OL, that is the fire at that time is well over 1,000 degrees. Firemen were told to open each one of their canisters. You're looking at the first tire being extinguished with water. Typically, if the tire is hot enough to burn, water will not completely knock out the fire, because the fuel source and the heat will continue to make the tire go from a solid to a liquid phase, and water will not be a good enough suppressant. Fireman exhausts his 2-gallon attack can. The next image is the same 2-gallon attack can full of National Foam. And foam, again, although it does some initial knockdown of the fire, is not capable of extinguishing the flame, as you'll be able to see by the fact that the flame continues to grow and continues to burn, even being coated with the foam product. The third set of tires, which are the 3 tires stacked with the canister of diesel inside, is now going to be attacked using fire blockade. And as you can see, there's quick extinguishment, quick knockdown. You see the black flame turn to a white smoke, and then actually steam is what you're looking at the latter part of the extinguishment. The fireman is basically putting blockade on any visible flame and then cooling down the tires. The flocculant effect of blockade is why you no longer see the dark black smoke. As you'll see now, the other 2 tires continue to burn, even though they were both treated with water and or foam. Blockade is still left unburning. The fireman takes the residual blockade, which was in the 2-gallon container that he did not use, and he puts out the tire with the foam, and then his assistant takes a secondary container of blockade we had and extinguishes the tire that was first attempted to put out with water. This was unprompted, but the fire department or the firemen felt like there was enough knockdown power that they could go and put these down, and that's exactly what you see. What you had were 3 Type B fires, all of different intensities, but you see the effect of water on a Type B fire, you see the effect of foam on a Type B fire, and the effect of blockade on a Type B fire. Again, the knockdown power is what we were trying to demonstrate, that a very small amount goes a long way. You got to see the same type fire fought by classical, which would be water, foam, which would be what is typically used in the industry now to fight Class B, and then blockade with its technology, which is different than foam, and the way we attack a fire.